A vertically polarized beam of light of intensity I0 is incident normally on a polarizing filter. So this is an example of a question from application of Malus's law, when we have a polarized light, or basically a wave that is being polarized by a filter. So the general formula for Malus's law, let me just write this down. So Malus's law states that the filtered wave I1 will be equivalent to I0 cos squared theta, where theta is basically the angle of rotation of a filter. So in this case, we have I0 as the vertically polarized light. So we do not have a raw light where all of the light is basically vibrating at all direction, but what we have is basically a polarized light, a vertically polarized light. That means the light are basically vibrating at an angle which is 0 degrees. So let's assume this to be I0, and then it passes through the first filter. Let's just label it as I1. So I1 is passing through a filter which is rotated by 45 degrees. So using the Malus's law, we can find out the intermediary wave I1 will be equivalent to I0 cos squared 45 degrees in this case. So if you plug in your calculator, cos 45, and then square it, you get 0.5. So it's just half of the original I0. Now, what about I2 here? So I2 will be relative to I1. So although the transmission axis of the second filter is tilted at an angle 90 degrees to the vertical, however, since the vertically polarized light will be passing through a first filter at 45 degrees. So the difference between the I0 and I1 is 45 degrees. So this 45 degrees rotated wave will be passing through the 90 degrees. So if you do not have the intermediary 45 degrees, then you would expect I2 to become 0. But in this case, because there's another a separate or a middle first filter, that is why your theta I2 here would be equivalent to I1 cos squared the second filter, which is 90 degrees, minus 45 degrees here. So it's not cos squared 90 degrees, which you can get 0, but instead it is just I1 cos squared 45 degrees. So it's basically the same formula here. It is 0.5 I1. However, we want to express I2 in terms of I1. Therefore, the final answer to express the intensity of the beam of light after transmission through the second filter, which is I2, would be equivalent to 0.5 I1 here. Substitute this equation into 0.5 I1, so you get 0.5 I0. So here you'll get half and half. You get a quarter of I0, where the answer would be equivalent to B.